Now, there's many ways, of course, to use the integral and to find the c value. So this is exercise 2204, and I've actually been asked to do this one. This is exercise number 3. It says each of the graphs below shows a derived function, that is, it's the differential f prime x. There's also information given about a point that lies on the graph of y equals f of x. So it says draw the graph. Actually, I'm a little bit unnerved by the word draw. Quite often these will ask for you to sketch, which means you don't really have to be quite so precise. So I'm not quite sure what they mean by draw, other than to draw it exactly as it should be drawn, complete with intercepts and turning points and other such labels and what have you. So let's go ahead and do all of that then, because they do say draw, and let's see how this plays out. So first of all, we've got a line here. We don't have the equation for the line, but it's pretty simple to actually turn that into an equation. So I'm looking at this and I'm noticing we have an intercept here, and I'm assuming that that is the intercept. So that's going to be, and when I say I'm assuming it's going to be the intercept, it looks like it crosses at 1, 2, 3. So that looks like y equals 3. And I'm hoping it's not something silly like 3.04 or something, because it looks like 3. We're going to go with 3. I'm also noticing the gradient looks like 1 along, 2 up, 1 along, 2 up. So the gradient, or the m value, therefore is going to be equal to 2. So we can write the equation of this very simply now, because we know that y is equal to 2x plus 3. There is the equation. Now, of course, if we've got the equation, we can now find if, well, in fact, really this is not, it's the equation of the graph, but it's also the derived function. So really, this is dy dx is equal to 2x plus 3. And of course, what I mean by that is this is the gradient function. And if you want to find out where the turning point of the actual function is, you can just make this equal to 0. So let's just do that for a bit of fun here. So 0 is equal to 2x plus 3. And I'm going to do the rest on a bit of paper, by the way. So that means that 2x is equal to negative 3. And it means that x will equal negative 3 over 2, or negative 1.5. So that there, where it crosses the axis, is also going to be the x value of the turning point. In other words, it's going to be some kind of presumably positive parabola, because this is all positive, and it's going to be a graph with a turning point that's centered around this here. We don't know how high it is or how low it is, but we do know that's the central point. That is, if you like, the mirror point, the halfway point of the parabola, because of course parabolas have symmetry, and that's one of the key features. We're also told, of course, that x is 2 and that y, or f of x, is 4. So if we were to integrate this, we can now find the actual equation of the parabola. Well, let's go ahead and do that. And we know it's going to be a parabola because we've got x to the power of 1. Well, when I integrate, I'm going to increase the power of x by 1. So if it's x to the 1, now it's going to be x to the 2, so it's going to be a parabola. So that means we're going to integrate it. Let's go ahead and do that. And again, I don't know how far they want you to do this or how much detail, but it does say draw, so I'm going to go ahead and just draw it, yeah? A bit of work, by the way, involved here, but let's just see how it goes. So we've got, and I'll restate the what we have. We've got dy dx is equal to 2x plus 3. So we're going to integrate 2x plus 3 with respect to x. So that's going to equal, that's going to be 2x. We're going to increase the power by 1, divide by the new power. We're going to increase the power by 1, divide by the new power. And of course, we're going to add a c value. So let's tidy that up. So that's now going to equal to, well, 2 divided by 2 is 1. So it's going to be x squared plus, well, 3 on 1 is 3. So 3x plus c. So that's really the y value now. That was dy dx. Now we've got back to the original equation. Well, we've got a c value, and we can solve for c, because fortunately we were told that when y is 4, x is 2. So I can put a value of 4 for f of x or y, and a value of 2 every time I see an x. So let's do that. So here's my y value. Y is 4, and every time I see an x, it's going to be a 2. So here it is 2 squared plus 3 times, oops, oh, well, 3 times 2, I'll write it like that, plus c. So 4 is equal to 2 times, 2 to the 2 is 4, plus 6, plus c. So, of course, I can subtract 4 from both sides. I can subtract 6 from both sides. So now c is equal to negative 6. I'll write that in. C is equal to negative 6. So now we've got our c value. So here's our equation. This is the actual equation we're going to be working with now. And now, rather than putting a c here, we know what c is. C is negative 6. So I can just plonk that on the end of the equation. So let's do that right now. So we've got y is equal to x squared plus 3x minus 6. Now, we've got the equation there, and I'm looking at that equation, and I'm thinking, that actually doesn't factorize particularly well. In other words, if I wanted to try and turn this into 2 brackets, I'm going to make this equal to 0 because I want to find where the turning points are or what have you. Oh, sorry, I want to find the, not turning points, found the turning point. I want to find the x-intercepts, in other words, where it crosses the x-axis, and I could do so by making y equal to 0, because of course when we have a graph, the y equals 0 line is the same as the x-axis. Now, I'm looking at this, I'm looking for factors of 6, which of course are going to be 1 and 6 and 2 and 3, but adding or subtracting these in any order won't get me a 3. So I can't just put it into brackets simply like this. In fact, I'll tell you what I'll do is I'll just make my life a little bit easy, and I'm actually going to, I'm just grabbing my calculator here. Let's have a look here. So I'm actually going to, let's clear all this here. So I'm just going to choose my solver. Oh, here it is. Oh, by the way, to get to that, in case you weren't sure, you go to menu, you go to equation, so that's 8 for me. So push 8. Some of you will have a different number which you have to push in order to get that, because you have the newer version. This is the old crusty calculator. Some of you have the new, exciting, polished, pristine version. Anyway, we've got some values here which we can just plonk in, and I'm going to use this. In the exam, by the way, if you had this and you were asked to draw this, and you were asked to find the exact x-intercepts, please use the quadratic equation. Don't do it. Well, you could do it on your calculator to check it anyway. In fact, I would definitely do that. But make sure you write it out. All right. So how does this play out? Well, we've got the coefficient of x here is 1, coefficient of x here is 3, coefficient of x here is negative 6. So I'm going to put 1, 3, and negative 6 in here. So here it goes, 1, 3, and negative 6. There they are. And I'm going to go solve. Here I'm going to have solve. Oh, and my x value is 1.37. So I'm going to write, so I'm going to have, I'm going to say if y equals 0, x equals, and I've got 1.3, in fact, I'm going to 1.37. I'm going to write all the detail here, by the way, or, not and, but or x equals, and the other one we had was negative 4.372. Negative 4.372. So they are the x-intercepts. That is where the x-axis, sorry, the parabola is going to cross. Now, so what would that look like on here? Let's just have a quick look. So here we've got negative, what have we got? 1.3, so we've got 1.3, so that's 2, 1.3. I'm going to say it's about there, yeah? It's about 1.3, and of course the other one's going to be negative 4.3. Negative 4, so negative 1, 2, 3, 4. Negative 4.3 is going to be about there. So this makes me believe that they actually want you to sketch it, because they haven't given you enough room on here to actually draw the thing. So, because it's going to be off the graph. Okay, but they are the intercepts nonetheless. Now, we also want to find out how low it goes here, and we don't actually know that looking at it, but we can find it, because we can take the equation here, which is, here's my original, here's the equation now, this one here. We know the center point, which is going to be this one here. So it's negative 1, where we got that? Negative 1, what did I write that out? Oh, here, I wrote it here. So there it is, x is equal to negative 3 on 2, or negative 1.5 if you like. So we can just punch this in immediately. So I'm going to substitute negative 1.5 into here to find out the y value. So in other words, this is going to go do this somehow, yeah, and I want to find out where y is down here. We know the x value of this is negative 3 on 2, but we want to find out what y will be when x is negative 3 on 2. In other words, we've actually got not just the x value, but we've actually got the turning point. Well, let's have a look at how we do that. So here's our equation, and I'm going to substitute into here the x value. So I'll put t dot p, or turning point, and I'll put y is equal to, so I've got negative 3 on 2 squared plus 3 times negative 3 on 2 minus 6. And just to fast track this whole thing, I'm going to just launch it straight into the calculator. I'm not going to mess around too much here. So exit, we go menu, exit. I'm going to go to 1. So I'm going to enter this straight away. So bracket negative 3 on 2 all squared plus 3 times negative, negative 3 on 2, close bracket, and we've got minus 6 on the end there, minus 6. So what do we end up with? We've got negative 33 on 4. I'm going to push the FD button, that one there. I'll push it there, and you'll notice that now turns from an improper to a decimal. So I've got negative 8.25. There it is. So y, when x equals negative 3 on 2, y equals 8.25, negative 8.25. So now if we're going to sketch this thing, what does it look like? Well, it looks something like this. So here's our graph. We've got the intercepts of, I'm going to call that 1.37. I'll just use the 2 dp's there. This is my x-axis, of course. Here's 0. We've got the turning point, which is going to be about there, which is going to, we'll call that negative 3 on 2, or negative 1.5. And over the other side, symmetrically about, say, there, is going to be negative, right here, negative 4.37. And it's going to go all the way down. It's going to go all the way down and across this point here, which is going to be negative 8.25. So it's going to go down here and turn here and up and cross here. Now, of course, it's also going to cross at this point here. And where's that point there? Well, fortunately, we know that when x is 0, we know when y is 0, the values of x. When y is 0, the values of x. But when x is 0, if this is 0 and this is 0, y will simply equal what's there. So I can just cross that out. X is 0, y will equal negative 6. So this is my intercept. It's y equals negative 6. That's my y-axis. There it is. And that is the graph, all nicely labeled. So you've got your, so we've got our two x-intercepts, we've got our y-intercept, we've got our turning point. And I'll actually just create that as an ordered pair. So it's negative 3 on 2, comma, negative 8.25. By the way, probably best to keep that at negative 33. What was that? Negative 33 on 4. If you're going to use that as an improper, you probably want to leave that as an improper, which would be negative 33 on 4 as well. Anyway, that's how I would draw that. Again, I'm not quite sure, looking at the question, just how much detail they want. But I would say that looks like the solution to me, and that's how I would find it. I hope that's been useful.